What's up, YouTube? We got another stream here on Twitch today that I'm just going to upload after I'm done here doing board tracing, laying out the traces on our printed circuit board. But before I start the stream, I just wanted to let everybody know that I've started a Discord server. I want to interact with more of you just as a community and help people out if I can. And so there's going to be a link down in the description. In the next video, I'll have something that's like up on the screen here that you can see the link to that. But it's an invite to my Discord server if you're interested in coming and jamming with me, asking me questions about any of this or help with projects and things. I want to help as many people as I can, as I'm able to. And so check that out down in the description below. And thanks a bunch for watching. So let's kick the stream off here. Okay, I think we're all set. It's time to do some trace layouts here on our ESP32 e-paper dev kit that we're working on. I have done a little bit, and so before we get into doing some of that to show you how that works, I'm going to show you where I ended up with some of the layout. Now, this stuff is not my strong suit. I mean, I'm going to be honest, I don't really know a lot about what I'm doing. I'm not like totally clueless at this. Don't take it that way. I'm not just making it up as I go, but I'm not a professional printed circuit board design layout person. And I do know some of the best practices that I've read about, but I don't really know all of them, and I'm probably violating some of them. And so if you do know what you're doing and you see something stupid that I'm doing, please point that out to me so that I can fix it. But this is where I ended up with all the component layout. You can see I still have two switches over here that I'm going to change the footprint for, but I'm not really worried about. I think you can see I have a ton of space over here to put things. And so I'll find a place to put the switches after I've done some of the routing. And so everything else, I think, is in a good spot. This is really like a puzzle. Like, as you're doing this, you're kind of thinking in multiple dimensions because you've got the front of the board, which is everything in red, and then you can route things on the bottom of the board as well, which this green trace right down here is an example of. This guy right here off of my JST battery connector. And so not only are you trying to place everything to satisfy these rat's nests, and so, like, you know, as an example I've talked about before, like this pin has to connect to this part of this capacitor. So placing them right next to each other, all we have to do is draw a little trace there, and you'll see that here in a minute as we get into this. But you're trying to think of that, but sometimes that doesn't always work. And so you have to think, like, how could I run something underneath? And then you have to worry about running long traces and crossing them over. So earlier in this process, I had put this chip, this is the FTDI chip, I put it way over here, but then I would have had to have run a long trace, whether it's on the top or the bottom, all the way across the board. And doing that is going to make it really hard to run other traces north and south here, because I've got to, you know, pop under and over, and you start, you know, you've got things crossing over and hopping under, and you're trying to figure out the best way to lay everything out to minimize the crossovers and things like that. And I still don't know if this is going to work out. I had it in my mind that I could do the layout, and then it would be not trivial, but it would be kind of a simple thing, a simpler thing to then go and do the trace laying. But I think I'm going to find as I go through this, like I think I have a lot of this figured out, but I might find that some of these are just not working, and I might have to go back to the drawing board. I don't know. Like, this is all part of the process, and I don't know if this is going to cause other issues. You know, I've got, for example, right here is my linear voltage regulator. Right here is my PMIC, my power management IC that handles charging the lithium battery. I don't know if having them this close together is going to be a problem as far as thermals. I don't know how my ground plane is going to lay out. So, like, these are all things that I'm sure somebody that does this professionally could see in their head and lay things out appropriately. But this, again, not my strongest point in all of this process. I'm much more of a firmware, software, front end, not front end like web stuff, but all of the post hardware stuff. I think I'm good at doing the schematics, but this piece right here, and again, we're trying to save money. and learn some stuff as we go and share that with you. And so there's a couple of things to note as we're doing this, which is the way we lay out the copper traces. As long as you're meeting the Fab House minimum specs, you should be okay. And so as an example, I'm going to pull this over really quick so we can look at it. This is PCBWay, who I'm using to do the fab and assembly. And they'll tell you things like, you know, the drill sizes that they support, the minimum trace. And they'll say, you know, they can do down to 4 mil traces or 0.1 millimeters. And they say, and this is important stuff to note, 4 mil strongly suggest to design trace above 6 mil to save costs. So, and there's a couple of things in here where they say we can go down to this minimum. However, we might charge you extra for that. And so if you need to, you can, but if you can avoid it, then, you know, in this case, I'm going to try and do 6 mil everywhere and only use 4 mil if absolutely necessary. And so it'll tell you all things about drill holes and solder mask and all those things. So you want to take a look at that. And then you set it up in KiCad in this little board setup icon up here in the corner. And we've got this tracks and vias. We've got track widths and vias. And this is something that I don't know a lot about as far as picking sizes. These are all in millimeters right now, but if we cancel out of here and change our grid to inches and then open that dialog back up, you'll see everything's in mils. And so I've got track widths of 6 mils, 8 mils, 10 mils, 12 mils, 14, 16, 20, and then different, I left these in millimeters because that's what the PCBWay numbers were given in. And so they come out to wonky mils, but again, I don't know. I'm half expecting that I'm going to submit this to PCBWay and they're going to say, yeah, you're going to have to change some of this stuff. That may be the case. We'll figure it out together and I'll share it with you. So again, we're all trying to learn together as we're going through this particular part. Now I have done a little bit of layout. You can see here, I was just testing the placement. Even here, you can see I've done a couple of different width traces. This one is fatter than this one because of the spacing requirements. I couldn't get these all laid out with the thicker trace. And so I've got most of the e-paper display run up and a couple of things. And again, I'm not entirely sure, but things like this, e-paper 3v3 here is pins 15 and 16. There's different ways to approach this where I have taken the traces out. You can see I've used a much thicker trace here because it's a power. It doesn't need a lot of power, but you know, that I just used the thicker trace. You could just glob these together and make them one solid pad, but again, you have to think about what the solder profile is going to be and if that's going to cause issues when you're trying to reflow the part. And so I think, again, I don't know, it's more best practice to have these come out and then join into a thicker trace later on. And you can see I laid a fat trace from here to here. Again, there's not really an exact science to this. You want your power lines to be able to carry more current when they need to. Like again, the e-paper display is so small. I could probably get away with a very small connection here. This is more of just being excessively careful. But coming over here, I have laid as big a trace as I can from the battery connector under. This goes under the USB connector. This is the bottom. It's green, so it's on the bottom side of the printed circuit board, all the way down here to where it needs to pop up and connect to the PMIC right here. And so I don't want to use a skinny trace there because this has to pull, you know, a decent amount of current to power the ESP32, especially when it's driving Wi-Fi. You know, we're talking 600, 700 milliamps. And so you don't want to use a tiny little trace there because it's going to get really hot. And if it's too thin, you could burn it out. And so similar things, I'm going to run 5 volts off the micro USB up to some power management up here. And this is where we'll see how this works. I've got my 5 volt stuff being created up here that I then need to get down to here, which this is a cool feature of KiCad I learned. They've got this highlight net. So if you select that and then you come in here and you say, I want to see everywhere there's 5 volts, my 5 volt net, you can scroll out and it highlights you know, I've got 5 volts here, this pin needs 5 volts, and then these pins all down here need 5 volts. So you can kind of get an idea of, after we create that 5 volts, how to run a trace. I'm going to run it, not probably, I'm going to run it on the bottom of the board. I can pop it up here, attach to there, and then bring it down and pop it up in here and connect to all these parts down in here. And so I'm not sure how well this is gonna perform. It should be fine. I'm not that worried about it, but you know, I've got my 3 volts coming down here, then my 5 volts coming from up here. But once I get them out of the PMIC, and we can show this here, let's go ahead and hit escape. The charge out is the output from the PMIC, which is, it'll choose between the USB 5 volt and the battery 3.7 volts or whatever it is, and then give me, it'll pick one of those. Again, if there's no USB connection, it's going to use the battery. If there's USB connected, it's going to charge the battery and just give me the USB, and then that's going to feed into this linear voltage regulator right next door. And that's why I positioned them like this. And then we get 3.3 volts out that's going to go straight into my ESP32 right over here. So I hope this works out for the layout, you know, running the traces. And so that's the layout and some decisions I made that I didn't show you guys. You know, it's really just, like I said, it's a puzzle. It's moving pieces around. Try this, flip it around, move it. Try this. Can I run some things under? And trying to envision the traces in your head without actually drawing them, because as soon as you draw them, and maybe that would be good to illustrate. Let's do R16 over here. We're going to go into trace mode. We want to select the trace that we're using. So I'm going to use, you know, 8 mils, let's say, and let's connect to there. That's connected. Now that trace is drawn, but then if you come back later and you say, oh, dang it, you know what? I think I need to move this. I'm going to do that. I'm going to move it. It's not going to drag the trace around for you. And so you want to wait as long as you can to draw traces, because once you draw them, if you need to move parts, you're going to have to come back and delete traces. And that seems like a hassle to me. And so I think as much as you can, get the layout done and then do the tracing. And so, and I did a little bit of tracing up here to see how routing some of this stuff would work. And I don't know why this is half drawn over here. I don't know what I did there. Okay, cool. So that's it. And now what we do is we just come through, and again, the name of the game now that we've laid everything out is to get rid of all of the rat's nest wires. And so again, as an example where it's not so crowded, you come up, the rat's nest shows that I need to connect this pad to this pad. So I'm going to come in here and I need to be back on my trace and say, let's do that. And then now that white line disappears and we're all set. Same thing. I'm going to go from here to here. And again, it's just, we're doing this over and over until we get rid of all of the all the white lines. Now, you'll see that the router kind of tries to draw things for you, but you have some say in it. Like if I started it here and I come to here, it's going to draw it like that. I don't really like how it comes up through here. Like I want it to come more down like this and come in, but like how it's drawing right there. But as I get closer, it's like, nope, I want to do it like that. And so you can use the control button to draw straight like that. It doesn't matter if I go left or right, it'll keep it straight. And you can also use the Alt button to kind of push this however you want. And then if I want to go to say like right here and then cut over, I can just click there, it'll break it, and then I can draw it straight over and I get a line, you know, like that, where I can control the shape of the pad a little more. I think it does its best to try and optimize that for you. And there is, and I'm not going to show this because I don't want to use it. There is a thing called an auto router. And a lot of the EDA softwares have this, where you just click auto route and it will try and draw all the traces for you. Again, it'll just satisfy the rules of like minimum spacing and things, but it's not going to, it doesn't know anything about the parts and how they might need to have bigger traces in some places and smaller traces in others. It's just going to do its best to automatically route everything and say, hey, I satisfied the net list. And so that's not what we want. And so that's it. Like I said, that's the name of the game. From here, this is where like I don't know what best practice is. Like I need to go from here to here. I can just, do that and say, is that good? Or should I, do something like that to have them connected? I don't know, and I don't know that it really matters. And this is where somebody that, has a lot of experience with this could probably have some good thoughts, look at it, and then say, let's do it a little different. But for now, I'm just going to play the game of let's connect all the things. And as best we can, you'll see that let's give an example. I'm going to come over here into this, and it's going to just draw it that way. I could come this way, and it's going to automatically, this little red outline is sort of the keep out of the trace. It's never going to draw a trace through that. So if I come here and I say I want to come right through the middle of this, it's going to say, nope, you got to come at least out and around with a spacing there. And so it'll give you some clearance. Again, if you want more clearance, you're going to have to do some clicking yourself to make that happen. And so I've got to get rid of that. I've got to get this pad up to here, but I also have to get this EPaper3v3 all the way down to here, which, as you can see, I reassigned some of the nets on the ESP32 to pull this off, which I thought was really cool. The way that the ESP32 chip is placed, I can come straight across from these pins over to the ePaper display connector, which is really ideal. It just comes right over, and so I thought that was really cool. And then same thing here, my EPaper3v3 is over here, so I can just pop right up and power the ePaper display from there. But then I also need to get 3.3 all the way up to here, which I'm going to have to run underneath, obviously. I suppose I could, you can do, so let's take an example. Let's come down here. I'm going to take this 3.3 volts. I'm going to push it out. And I'm going to say I want to come up here. And it'll draw it up around everything. So like I could do that. And that gives me my 3.3 up there. The problem with that is maybe nothing. There might not be anything wrong with that. I've got to get these pre-VGL and pre-VGH down to here, which I'm going to do, through this back area like that. Pre-VGH is up, so I could do this right there. So I guess taking the 3.3 volts from there does work. I don't think there's anything else that I need to route through that back area there. So that might do it for me. Okay. Well, we'll leave it there for now. I do need to get clock. Yeah, see, okay, so what I'm going to need to do, clock and MOSI, master out, slave in, I can't squeeze them through here to get over here to clock, and then I don't even know where, there's master out, slave in. This is another example of, I guess I could try and come around here. This is funny. Look how it's going to try and draw this for me. It's going to go all the way up and around there. So it tries to help you, and it says, "Oh, I can't find a way to get in there." But it's doing its best. But I could do that. That's weird. That's creating a really long trace that feels unnecessary. So what I was going to do is punch these out. And so let me just show an example of that really quick. You can come out of here. You can press the V button. Let's keep it straight. Press V, and it'll say, let's drop a VIA. That's what that stands for. Right now, I'm dropping a bigger one. Let's set it to the smaller size, 0.6, 0.3. So come out of here, press V, and now you'll see that I'm now green, which means I'm on the bottom of the board. And now I can just draw over here, you know, whatever kind of a line I want. And like hit V again, pops it back up, and then ta-da, I've attached master route slave in. Now I don't love that route particularly, and so this is the kind of stuff that you have to, you know, you're thinking lots of steps ahead, because I'm gonna Control Z that whole deal I just did there, because the way I drew EPaper3 coming so close on this angle here, it makes it hard for me to create vias right off of SPI3 Mosey and SPI3 clock. And so running that 3.3 volt might still be fine, but what I might want to do is slide it out. And now watch this. If I want to slide that now, I haven't quite figured out a way to do that, because if I do move, it's just grabbing that chunk of it, and it doesn't, you know, it doesn't stay connected. And so when you're drawing it, you need to know where you're moving. There's probably a way to move the whole track. I'm not sure, but I'd want to draw that one a little differently. So anyway, that is kind of what we're doing. I'm going to undo some of those and just leave that there. That's what we're working with here. We're just, again, connect all the things and get all the white lines to disappear. Ground, you're going to want to save for last, as far as I understand, because what we'll do is we will draw a ground pour over the entire board, essentially, and KiCad has a feature that will then automatically draw in every open space that it can find that doesn't have traces. It honors the trace spacing and creates basically a ground plane everywhere, and will connect automatically every ground point to that big ground plane, so you don't have to worry about, you know, I won't come in here and do things like, let me get back to my trace. You don't have to come in and do things like this, because once we do that ground pour, it's going to automatically connect all these to ground, so I don't have to worry about drawing all of those. And so we'll save ground for last, doing the pour. And so I don't think I will sit here and make you watch me route all of this stuff. I think I've given you an idea of how this works and kind of the things that you can think of and do and move. And so I will chip away at this and figure out, maybe talk about the struggles I had. Like I'll come back, I'll do another stream once I have hopefully all of the traces laid, and I can talk about anything I changed or moved, or problems that I ran into, or things I learned. And so that's gonna do it for the stream today. That's what I'm working on this evening. Again, I don't know that there's much value in you sitting here watching me. I can't talk to the camera and do the trace routing at the same time. That's going to be a disaster. I need to really focus in on this, because it takes a lot of my CPU cycles in my brain. So thank you so much for watching. I really appreciate it, and look forward to next time, where hopefully I can show hopefully the finished trace layout, and then we'll be just about ready to go to fab. We got a couple of other things that we need to take care of before that, like part selection. I'll go through all of that so you can see the process involved in that, and we'll get this out to fab so we can get some of these back and see if they actually work. So thanks for watching.